Hi, this is Fabio Messina, creator of the Godfeather Toolkit. In this video I will show you how to create interesting parting patterns on your barbs using the features of the Godfeather Toolkit. Let's start with the basics. Partings are created when the Barbs orient node gives the initial shape to the barbs. You can plug a Barbs align gaps node to generate parting points on the rakeys. This node gives the user settings to change distribution, shape and randomness of the parting effect. After setting the push amount to 1, this demo is showing what the different sliders do. We have the density of the parting points, the random seed for the way they are scattered, the relax iterations for creating even distributions if you want. The normalize push option is a setting that prevents barbs from being pushed beyond their segment. It basically adjusts the push amount considering the other parting points. You probably want to always keep this to the default value of 1. And then we have the split overlap slider, which affects the probability of having a parting point that attracts the barbs instead of pushing them away, something that can add a lot of realism to your feathers. We will see how to deal with this kind of parting later in the video. Now, the first thing we want to do is to give each feather a different distribution of parting points. In order to do that, we simply connect the feather ID attribute to the seed input, and here we have a random distribution of partings on each feather. We can also decide to roll the dice again and add a global seed to the feather ID. In this case I'm adding a constant, but you can also add something driven by a map or from values set manually in your feather primitives. Another variation we can create is on the depth of these shapes. If we connect a barb ramp to the push amount, we will be able to give the parting the shape we want, and we can also use the scale parameter to make it smaller. Of course we want this to be random, and so we are going to connect a random constant to the corresponding input of the ramp and use a special barb attribute as seed. The segment ID, which is an ID assigned to barbs after they are split by the parting points. Now we have a mix of deep partings and small dents. We can keep refining these because being in control of what we do is as important as adding randomness. For example, maybe it's not good for the short partings to be as wide as the deep ones. So what we can do is to use the same random factor and reduce the push amount as well. And if this is just too much, we can be more accurate by remapping the value before using it with a remap node. This way it will always keep a minimum of 0.5, for example. This way we have a natural, organic and very diverse distribution of partings on all our feathers. One of the key features of the Godfeather Toolkit is the ability to combine values belonging to different domains. Constants can be mixed with ramps referring to the barb or to the spine. For example, let's say that we want to prevent the parting effect from changing the shape of our feather tips too much. We can create a feather spine ramp and protect that spot, simply multiplying this ramp to the small network we already created. And if your graph starts being a bit crowded, remember that you can always create a Godfeather subnetwork. We're not done yet with adding richness and variety to our template. What about random density for these partings? We can create another random constant, still driven by the feather ID, and make our density to be randomly picked from a range. In this case, I'm setting quite a big range. This way we'll get feathers with a lot of parting shapes and some of them with just a few. A final touch, just to show you how possibilities with the toolkit are really endless. We can go back to the subnetwork we used to build the push amount and create an alternative shape for our partings, something that opens the barbs and then reconnects them at the tips. Then we can create a blend node to be able to switch between the two. We can drive the blend with some random value. Using the segment ID as a seed will be fine. This way we'll get different shapes even on the same feather. And if we don't really want to do a linear blend, but we just want to pick any of the two shapes, we can connect the random value through a remap that will act as a threshold. Now we have an even more diverse look on our feathers, and we achieved this creating just a single template, which will make our character easier to maintain and won't force us to change 10 or 15 feather templates every time we want to apply some global change to our character groom. We came to the end of this small guide on Barbs parting with the Godfeather. The very last thing we have to look at is how parting can affect further Barbs processing downstream. The parting process writes a segment ID attribute on the Barbs, something similar to a clamp ID, and it will actually combine with the Godfeather clamping node with clamps, which will be a subdivision of the segments that you can use to get an even more refined look. But now we will use it simply for what we saw earlier, the overlapping partings. What we have to do is to slightly push away each segment using a curl node. And then, well, you will know at this point, use a random value driven by the segment ID. Done! Now our feather is clean from artifacts. And that's all for this guide about Barbs parting created with the Godfeather. I hope this tutorial will be useful for you, and see you next time.